Hello again. Let's begin now with unit number 6, choice under uncertainty. Now, question number 1. If a consumer has the utility function x squared, then the consumer is of course risk lover. Yeah, because the utility function is convex, is U-shaped. Okay. X squared is the typical, the easiest parabolic curve. Yeah, and we know that when we have such a graphic representations of functions, we have risk lover, prey, so okay. So perfect. Now, question number 2. Mark has the possibility of winning 30,000 euros if his app is bought by a big firm, or winning 5,000 euros if he goes ahead with the project till the end. The probability of the first scenario is 0.45. How do we call this situation? Okay, what Mark has is the possibility of winning 30,000 or the possibility of winning 5,000, each with its corresponding probability. So what Mark has is a lottery. Okay, Mark has a lottery. Well, we know that the lottery is a set of outcomes and the probability of each possible outcome. Okay. Now more. The certainty equivalent of the lottery that pays 100 euros with a probability of 0.3 and 9 euros otherwise is... Well, be careful with this question, because the certainty equivalent is something like personal. Yeah, it's something that comes from the utility function of each consumer. Okay, so as we don't have here the utility function of this consumer, well, we can't calculate the certainty equivalent. Okay, the certainty equivalent is not from a lottery. The certainty equivalent is for a player or for a consumer that faces a lottery. Okay. Well, if we remind how do we calculate it, as we calculate it by this formula, we need the utility function. So okay, now question number 4. A utility function that verifies this, the expected utility is equal to the utility of the mean value, represents, well, this is just a definition and we should know it. It represents risk neutral attitude toward risks. Sorry. Okay. Well, as it's just a definition, we shouldn't need any more. Okay, the graphical representation of such a utility function is linear. Okay. Well, question number 5. A consumer faces the following situation. His wealth will be 30,000 euros or 20,000 euros with probabilities 0.35 and 0.65 respectively. After maximizing his expected utility subject to a constraint found by considering a certain insurance, he decides to insure 10,000 euros. The consumer has been overinsured, underinsured, has taken out full insurance, or there is not enough information. Well, we don't have the utility function, but we don't need it. The maximum loss here is 30,000 minus 20,000, 10,000, and this consumer insures all these possible the maximum loss. So the consumer is taking a full insurance. Okay. Well, remind that we use L usually for the maximum loss, to denote the maximum loss, and we use K to denote the quantity we insure. Okay. Now, question number 6. The utility of the following lottery: I win 100 with a probability of 0.6, I win 20 with a probability of 0.3, and I lose 10 with a probability of 0.1 is 65 if the utility function is, well, the utility function may be one of these functions. We can't know this without doing calculations. Okay, so we should try to prove with each of these. Well, I tell you that the answer is this one. Okay, the answer is this one, and I will show you now. Okay, you should begin with A, try it. You will see that the utility of the lottery, so the expected utility, is not 65. Then try with B, and you will see that it's the correct answer. Okay, the expected utility, or the utility of the lottery, is 0.6 times the utility of 100, that is 100, with this utility function of B, plus 0.3 times the utility of winning 20, that is 20, plus 0.1 times the utility of, be careful, losing 10, so minus 10, and this is equal to 60 plus 6 minus 1, so 65. Okay, so that's why B is the correct answer. 7th, if the lottery graph, the following graph represents the utility function of a consumer that faces a lottery, this consumer is, well, this consumer is clearly risk lover. We told before, yeah. So we have convex utility functions. We are talking about a risk lover player. Okay, perfect. Now, if John is going to win 10 euros with certainty, his certainty equivalent is, of course, 10 euros. Yeah. If John is going to win, yes, 10 euros, how much money would he accept to forget about that bet? Well, that bet is not really bad, but you know what I mean. It's exactly 10. Okay, he wouldn't accept 3.16 for these 10 euros. Of course, he would accept 100, but this is not the certainty equivalent. Okay, well, perfect. Now, question number 9. Michael's utility function is the square root of x, and he faces the lottery, win 5 with a probability of 0.9 and win 1 with probability of 0.1. What's his certainty equivalent? Okay, we should remind that this is the way we find the certainty equivalent with calculations. Okay, so the utility of the certainty equivalent is the square root of the e of the certainty equivalent. This is equal to 0.9, the probability of the good scenario, the good state of nature, times the square root of the outcome 5, plus 0.1 times the square root of this profit, this outcome, that is 1. So if we do these calculations, we find that it's 2.11, and we elevate it. If we elevate it to the square to isolate CE, we find 4.46. That is so the certainty equivalent. Well, Michael's utility function is the square root of x, and he faces this lottery, the same one. If he's thinking about buying an insurance with a per euro premium of 0.10, he will insure for, okay, we know that when we have risk-averse player and he faces, sorry, fair insurance, yeah, with per euro premium equal to the probability of that scenario, he will insure for all the possible loss. Okay, he will buy a full insurance. So as the maximum loss is 4, it's the difference between 5 and 1, so the answer should be 4. Okay, we could do the calculations. I recommend you to do them at home, and you will find that we are correct. Okay, well, but we'll see. We've seen this so many times in class that we know that this will happen for sure. Okay, Mikkel has the following probability distribution for his portfolio return under different scenarios. Okay, the return will be 20% with a probability of 0.6. Okay, this will happen with a market boom. Okay, the return will be 5% with a probability of 0.3. This will happen if the market evolves normally, and you will lose 10% with a probability of 0.1, and this will happen in the scenario of a bad evolution of the market. Okay, then if his utility function is, okay, here it should say u, okay, the utility of r equal to this, would he prefer a risk-free investment with a return of 8%? This rate, remind from this investment, is called a risk-free rate, yeah, and it's denoted usually as RF. Yes, because a sure return of 8% is not easy to find. It doesn't seem to be the correct answer, of course. Yes, because the certainty equivalent is 9%. Yes, or yes, because the certainty equivalent is 6.15%. So it's quite clear that we need to find the certainty equivalent. Okay, so we know that the certainty equivalent comes from this formula. Okay, we need to calculate before the expected utility. So Mikkel will earn 20%, and its utility will be this 20 elevated to 1/3 times the probability of happening that scenario plus the other scenario with its probability and the utility of the outcome and the probability of the bad scenario, okay, with the utility level if the return is minus 10%. If we do these calculations and if I did them okay, the result would be 1.93. So now we apply the formula for the certainty equivalent, and then we introduce the certainty equivalent, the utility function, and we find this is equal to 1.93. Okay, we equalize it to 1.93, and we look for the value of CE that solves this equation. Okay, well, then we have 7.19%. if I did it okay, then Mikkel has the opportunity of having a sure sure return of 8%. Okay, this is higher than the certainty equivalent, so Michele should accept the risk-free investment of 8%. So the correct answer is Z. Okay, well, let's make a little break and we will continue with the second part of this sixth test.